Alright, PreCalc, I'm setting up here. Hang on to your seat. I guess that's good enough. I got the board in. Alright, we're going to be looking at this video after Thursday's class. So what would the date be? After Thursday's class, let's see, we have 19th? I hope that's right. 1/19/17. Alright, Thursday's night, or after Thursday's class sometime. Alright, we are looking at decomposition by partial fractions, and specifically fractions. Tonight, or today, whenever you're looking at it, we're going to look at that when we have repeated, well, we already looked when it had repeated factors. This time there's going to be no repeated factors. No repeated factors. And we're going to do when some of the sum factors are quadratic. Alright, so that's our goal for today, what to do. Now, I'm seeing quite a bit of glare. Let me see if it's what it looks like when I turn off the lights. It actually shows up a little better. Alright, I think I might give it a try in the dark. That's weird. I can hardly see the board, but it looks like on the camera it's showing up rather well. Alright, for example, this is what I mean. Suppose that I have, where am I on the screen? I can go everywhere I want. Oh no, 3x squared plus 4x plus 4 over x cubed plus 4x. Alright, so I want to decompose this using partial fractions. And let me see if I can get the pesky light to stay off. Alright, give it another try. So I'm taking this expression and I'm going to write it in using partial fractions, rewrite it, decompose it, pull apart, and make it useful in other cases. Other situations where you'll need that. You always want to start and factor the bottom. Leave the numerator as it is, factor the bottom. These are two terms. The way you factor them is you just pull out what's common to both. So I'm going to pull out an x and check if that can be factored any further. If that had been a minus sign, it would have been a difference of two squares, but it's not. So it's not factorable. We call it irreducible, and it is quadratic. That means the highest power is 2. Up to now, whenever we factored, we got factors that were linear. Their highest power was 1. So the highest power of the variable was 1. This one is 2. So we are in some quadratic factors. X is linear, but this one, x squared plus 4, is quadratic. Here's how we handle that. We're going to continue writing each of the factors in its own fraction, like we've seen previously. But what happens is this gets an A, and we're going to add them together. But when we get here, instead of just a B, because this is quadratic, this is going to be linear. So that means I'm going to do bx plus c. So notice a linear expression sits on top of a quadratic factor. So that's how that works. So let's continue and solve. The method is similar. I'm going to take this fraction. I'm going to try to find a, b, and c. I'm going to take this rational expression and multiply it by the LCD, which is the least common denominator. So I'm going to use this factor and this factor. I'm going to multiply it times each of the expressions in our problem, you'll notice that this and this are alike, so they cancel, leaving just the numerator. This times this, the x's will cancel, leaving x squared plus 4. And this cancels this, leaving an x times bx plus c. Alright, so with that, we're going to continue much the same as you remember from the other problems we've seen like this. We're going to play let x game. So, let x equal 0. And the reason I picked 0 is I see that will eliminate that and simplify a whole lot for us. So putting in a 0 everywhere there's an x, I get 3 times 0 squared, which is 0, plus 4 times 0, which is 0, plus 4. So only a 4 on the left. Then a times 0 squared plus 4, which is a times 4, and this all zeroes out. So very quickly I see 4 equals 4a, or a equals 1. So that's my first mystery solved. So I'll go in here and I'll put the 1 in for a. Alright, let's play let x equal again, because we love this game. Not 0 though. Alright, I can't see a value that I could put in for x, so when I square it and add to 4 that it will ever zero out. Because if I put a negative 2 in here and square it, I get a positive 4, which becomes an 8. So I can't use the strategy that I used previously. So what I need to do is come up with some value that gives us more information. So I don't care what it is. Nothing will zero anything else out. So I just picked the smallest number that's the easiest to work with. So I picked 1. And you could pick 101, and it'll still give you the right answer. There'll be a lot more slop to deal with. Alright, so again, I'm plugging it in this line. So I get x equals 1, 3 times 1 squared plus 4 times 1 plus 4. Over here, I get a I already know to be 1. I already calculated that. So when I hit a, that's a 1. And this is a 1, squared is 1 plus 4, so we have 5 times 1. 1 times b plus c. I don't write the 1. b times 1 plus c. Alright, so that gives us 11 equals 5 plus b plus c. Move the 5 over, and I get 5 from 11 is 6. Equals b plus c. Alright, so that's not enough information because I need b by itself and c by itself. So I'm going to have to play let x equal again. Alright, but I'm not sad about that. Are you? Alright, so now, does this show up? I think it does. I'm going to let x equal, you could say 2 or 10 or whatever. I'm going to pick minus 1 because I like to keep my math fairly simple. And I can turn this a little if I need to. Alright, let x equal negative 1. So again, putting it in on this line right here. 3 times minus 1 squared is 3. Plus 4 times minus 1, minus 4 this time, plus 4. Equals, and now I'm putting in a minus 1. When I square it, I get a 1, plus 4 is 5, and a I already know is 1, so I get a 5, plus a negative 1 times b times negative 1 plus c. So that's a little sloppy. Minus 1 times b times minus 1 plus c. Alright, so cleaning up that mess, I get on this side a 3 equals 5. Minus 1 times a minus b is a plus b. And a minus 1 times a minus c is a minus c. So I move the 5 over, minus 2 equals b minus c. That's not enough information either. So what I do is I combine these two statements. I have two equations and two unknowns, and I'll find a spot on the board where I can work with those. Let's see if it'll show up here. So I'm going to write this one first. 6 equals b plus c, and minus 2 equals b minus c. So I'm going to add these two together. Why? Because one of the terms will drop out and the other one will be solved, we can solve for. C and minus c drop out. 6 plus minus 2 is 4. B plus b is 2b. So I get b equals 2, dividing both sides by 2. So this is one of my answers. So here I'm going to put b equals 2. Where was my first answer? 1 equals a. I'll put it in a box. And this is in a box. So all I need now is c. But I can use any of these statements, either of these statements. So 6 equals b plus c. But now that I know b, 6 equals 2 plus c, or c equals 4. So that is my third unknown constant. So that is the decomposition of this original problem. Did it all show up? Not so sure. Alright, so this is the original problem. I can decompose it with these partial fractions. Where did I write it? Right here. 1 over x plus 2x plus 4 over x squared plus 4. So this is the decomposed expression that I was looking for. Alright, recapping. Now our expressions can have quadratic factors in them, and they are going to be set up differently. Recall we had an a here over the linear factor, but over the quadratic factor I put a linear expression. Linears have a variable degree 1 in them, bx plus c. So you have to recall that's the new starting point when we have quadratic factors. There's another case where you have repeated quadratic factors, and we're not going to go into it. So I just want you to know that it exists, and this will give you a taste of partial fractions, enough to get you through your future math courses. Alright, so that's all for tonight. See you later.